Okay, so this is the implicit differentiations. Okay, so what you need to do is just adding dy dx when you derive dy, and treat the x as usual. And also, it's easier to derive the ln x. Okay, you know that this is just 1 over x, right? But let's try to use the y is ln. Okay, let's change this to e. Okay, so you have the e y and then it's x. Okay, and derive this. So e become e y, and don't forget dy dx. Okay, and then x is just 1. So dy dx is 1 over e. Okay, and this is actually 1 over e. Y is ln x. Okay, so you can also prove with the implicit differentiation. So it has a useful. So you can have more and more easier for proving. Okay. And how about if you have fx is x to the x? Can you derive? Yeah, this is just for your. You can try at your home. I will move back to our quiz. Okay. Do you want to know the answer? Okay. Let me just move back to our quiz. Okay. I will go back implicit if you have time, and maybe next Thursday. So our quiz. Okay. Okay. Number one, if f is a function, then fs plus t is equal to fs plus ft. True or false? False, right? Yeah. Okay, good. Uh, if you want to know why, you can check just using the easy function. You can just use x or x squared, and then maybe s is 1, t is 2, and then it will proving that it's not equal. That's also fine. Domain and range. So this 3 minus x should be greater than 0. 2 plus x to be greater than 0 and equal, okay? Because it can also be a 0. So if you want to make sure, you can draw the line number, okay? You can use 2 here, 3 here, okay? So I think should be here, right? So this is your domain. Oh yeah, minus 2. Huh? Yeah, domain. Yeah, half. Maybe to 7 or 8. And how about the range? Okay, the range, you put back your domain here, try, okay? Put 3 here, so you get, right? And then put 2, -2, it's plus, right? -2, it's canceling. So this is the range. Range, okay? This domain, okay? And this number 3, you have this, okay? But because the question is only asking use transformations, okay? You don't need to change all the formula there, okay? Okay, see here. Okay, see this 1.5, this is 3, it's twice. So the y is twice. And see this 0 and 3, it's become 2 and 5. So it's moving to the right 2 points, right? So you just, the new functions become, let me just write y become 2. Okay. Yeah, that's it. If you just finish like this, still got full point. No need to expand. Okay. Let me just show you the answer. Okay, and then I will explain to you. This is number 1, 2, already explained. Number 3, you can expand, but just until here, that's fine. It's still full point. Okay. Anytime you get the absolute value like this, okay, you need to think how it can happen. Okay, so it can happen with positive x or negative x. It depends on x, right? So because you have some value, you have at least two approach. Okay, you can approach from right. This is right, right? This is left. Okay, so you can solve this. So from here, then you get that this is not the same. Then you can say this doesn't exist. Okay. Or here, okay. There is two way. Okay, you can also multiply this with the another to rationalize. You can also get the same answer, but I'll prefer to change to another variable because square root sometimes it's making difficult to calculate. So I am using this with 6 here as our t. So when I square this t, it's become this, and when I cube this, it's become square root of x. So change all to this t, and don't forget this t also need to check whether it's still 1 or change. Okay, so as x is going 0, t also the same, right? So when x is going, this should be 1. Sorry, this should be 1, 1. So you get this expression, expand, and then you get 2 over 3, and plug in this 1. You get 2 over 3. Okay. Okay. Next one. This part. Okay. Um, this is, I think, faster. So you have this x4 cosine 2 over x. Okay. So first, to define your maximum and minimum number, you can get that number from this cosine, right? You can have cosine minimum is -1, maximum is 1. Okay, that's the uh, available maximum and minimum for cosine. And then from here, multiply with the x with the fourth, because x with the fourth is always positive, right? So it doesn't matter here. So I can multiply this with the same x to the fourth. And then approaching with limit, and we get the squeeze theorem. Okay. So when you approach this is 0, approach this is 0, then the whole thing becomes 0. Okay. Okay. Last part. Okay. So you have to look for this part and this part. Okay. The absolute value. Okay. So the first absolute value, you can have positive and negative. Okay. And for this one, you can have this half. And this greater or equal, it can be this is just greater, this is greater equal. That will be the same results. Okay. As long as you're consistent, you're writing it, then it should be fine. And this part become negative half. Okay. So now you have negative half and half. Okay. Where is 0? It's in the middle here, right? 0. So you need to find this expression. So you need to have at least this. So change all with the x is greater than negative half. So you use this one, 2x plus 1. Okay. And then x less than half, you use this one. And use that information to solve that this is actually negative 1. Okay. Okay. Any questions first? Any questions? Okay. Any questions? Okay. I think we can just finish the class today. Is that okay? And just continue next Thursday. Okay. Hopefully I can grade your score, but I think maybe next Tuesday. Okay. Okay. So uh, okay, class is finished, and I will check your quiz. Okay, your online student. Thank you for your attention.